Any problem? How you guys really did it?
Yeah, I'm trying to find it right now.
Maybe we can
Oh.
go through 15.
15.
It's rotating.
Yeah, 15,
sphere.
that's one. So this mentioned by Ray, right? So Neil, could you mention another one? Or just pick up randomly.
Yeah, I'll pick. Maybe I'll pick 15 because I didn't really like that.
You also want
that
15. Okay.
Yeah.
Except besides 15, we may have another one. Okay. So let's say 15. Okay. Then we can make a whiteboard this side. Yeah, suppose that a belt drives two wheels of radius 15 and 25 centimeter as shown in the figure. Determine each of the following quantity given that the angular speed of the smaller wheel is 600 RPM. First, the angular speed of the smaller wheel in reading per minute. So A suppose not too hard, right? Yeah. If you know answer, just write on screen. For example, here for Neo, here for Ray. Yeah. Anyway, so just multiply 2 pi. Okay, good. Now let's go to part B. The linear speed of a point on the circumference of the smaller wheel. Okay, this should equal to V equal to omega. Yeah, we call this like angular speed like omega, right? So omega times radius. Yeah, if we call this is small radius, this is big radius. So anyway, if we want, it's just time r. R is 15. So this will go to 180 and 2 more 0 pi. Yeah, but the unit is just cm per minute. Right? Then part C. The angular speed of the larger wheel in reading per minute. Angular speed. So first, the linear speed on the circumference of the larger circle or larger wheel still the same as this, right? Yeah, if we call this is V1, then V2 equal to V1 equal to, yeah, then let's call this omega 1. Call this omega 2 times R. Then omega 2 equal to V2 or V1, they are the same, divided by R. So over 25. So this should equal to I
Mhm.
yeah, the unit is radians per minute.
Mhm.
The linear speed. Oh, hold. In radians, yeah, in radians. Then part D, the angular speed in RPM. So just W2 divided by 2 pi. Then we get RPM. Right? Yeah, that's all for this problem. You can screenshot. Okay, so I suppose you're done. Now, Neil, could you pick one more?
Maybe
Yeah, if you are not sure, just randomly pick up one. Not too hard, but also not too easy.
maybe 11. Wait,
11?
no, I don't know.
Hmm.
11 or maybe 7, no, 16, maybe 16. I don't know.
16. Okay, let's do
Yeah.
16. If theta is an acute angle in a right triangle and tangent theta equal to t, express the other in term of t. Okay. So this is an acute angle. We can do it in right triangle, right? Yeah, if suppose this is theta, this is right angle. Tangent is theta equal to t. Then we can set this is t, then this is 1, right? Then the hypotenuse should be t square plus 1 square, then take square root. Yeah, when we have this, we can easy to get first cotangent theta. Of course, it's the reciprocal of tangent, then t over 1, right? Now, could you guys do, for example, for Leo, do this sine theta equal to what? Secant theta equal to what? Secant. Then for ray, you do cosine theta equal to what? Cosecant theta equal to what? And rationalize your answer. Okay, let me say. Sine theta. Yeah. Okay. Yeah. Then how about here, cosecant?
Well, I think I did this one wrong. I'm redoing it. I'm
Yeah.
resolving it.
Yeah, actually we can get from this, right?
Yes.
Yeah. Another way is it's the reciprocal. Anyway, so it's just like okay, you go ahead. Yeah. That being said, it's this over this.
Mm-hmm.
T squared plus 1 over t. Right?
Mm-hmm.
Is this secant. Yeah, then let's go to next chapter. Yeah, we'll try to go through all the chapters of this book. So we need a kind of speeding up. Let's see how many sections. Oh, this is not a very big chapter. How about 9? Yeah, each has 4 sections.
Mm.
8.1 trigonometric function of real number. Yeah, anyways, we'll use here is a definition in unit circle for trigonometric function, right? But we still use the angle as t or theta. X, Y here show the coordinates of the terminal point. Yeah, but in the habit of represent function, we just want to use x as input or independent variable, y as the output or dependent variable. So if we want to keep the fact, yeah, I suppose very soon we will mention, we'll still use x as the angle, which is the input for the function, y as the output. But here still mention something. Just go to calculate its value, right? Okay, I think we'll go past this. Question for review and preview. Yeah, again, so t just means the angle. This is still something basic. Yeah, I don't think this is something new. To rationalize. Yeah, here use some special, we wanna simplify this. Yeah, if we use u to substitute, use secant theta to replace U. Then we have this. Use some rule from trigonometry. We can simplify it as this. Yeah, here assume theta is within this. That's because from this, we can show the domain for U, right? So we have U squared minus 1 must greater than or equal to 0. So U should greater than or equal to -1 and less than 1. By the way, is here shows something U that the making the substitution. Oh, so this is the given condition. This is the given condition. Assume this. Yeah, that means that we use a trigonometric function to do some simplify, right? Here, keep going has some simplify. We'll do it in exercise. And here show some property. Cosine negative t. Cosine of negative t equal to cosine t. Sine of this. Do you guys have question why this happen or why this are true?
So
Or you
cosine
just think maybe
is like related to the x-axis. Like this, it represents the x-axis. So like, even if like it sounds like, you know how like it turns negative, it just like
yeah.
it
So actually, I
reflects
suppose we
y.
can go to draw it, right?
Yeah. It
Yeah,
reflects
for example, if
y-axis.
angle is t here, then where is the place for negative t?
It's at
So
the
it's
third
here,
quadrant.
right?
Yeah, it's there.
Yeah, it's here, negative t. Then if go to check its cosine, they have same cosine, right?
Mm-hmm.
But they have opposite sine, and also they have opposite tangent. Yeah, that's the reason. Yeah, okay. Make sure if you have question, let me know immediately. Yeah, so this will be very useful in simplify, right?
Yeah.
Yeah, this is easy because sine and cosine are both uh uh are both we call it a periodic function, right? So they have same sine and cosine, and also same others like tangent. Okay, the final rule. If t plus 2k pi, then they have same sine value and sameness and same cosine value. This we call periodicity. Okay, let's try some exercise. B. Yeah, just part A and B. Yeah, Ray, could you pick one and let me do it? Just randomly pick odd one.
Let's do 33.
33. Okay. make the substitution. And show that the result is this. Okay, so let's try first. I suppose we need a whiteboard. Good. We better have a whiteboard. So this is 1 over, now u is 5 secant theta, so it's 25 secant theta square minus 25, 3 over 2, right? Then keep going, we can write as 25 is a common factor, so even 25 is 5 square, then 3 over 2. Here we need to know secant theta square minus 1. Yeah, if we are not quite sure with it, we can change it to like sine, cosine. Anyway, so it's secant theta square minus 1. We'll see how to simplify this. This is 1 over cosine theta square minus 1. Then it's cosine theta square. 1 minus cosine theta square, right? So this is just 1 minus cosine theta square is sine theta square. Cosine theta square, which just means tangent theta square, right?
Yeah.
Yeah, then we get, yeah, let this go here. We get tangent theta square, then take power of 3 over 2. Yeah, then keep going, we have. This is just 5 cube, so it's 1, 2, 5. This is tangent theta cube. So we know tangent theta is just the reciprocal of cotangent theta. Then we get it's cotangent theta cube. Yeah, but we also write it this way. Okay, hold. I will not go to write it. It means actually we use this, right? This looks like you can save the parentheses, correct?
Mm-hmm.
I suppose that's the reason why actually people write it in this way. So anyway, it's this over 1 to 5, which is what we want, right? Okay, if you want, you can screenshot.
Oh.
That. Now let me find something for you. So 5 and 9. Oh no, not 9. 7. How about yeah, so Leo do this. Which one? Let me say. This one. Just do B. Then Ray do this. Yeah, just B. This is for Ray. Oh, you are so quickly. Okay, Neil, good job. Then how about let me give one more to you. It's not so hard. Yeah, Neil, keep doing this. Cosecant. So Ray, this is your answer, right?
Mm-hmm.
Why I suppose it's not correct. Let me say, where is this angle? Could you draw it?
Wait, this is wait a sec.
Yeah, if it's wrong, don't erase it. Just means, oh, it's not correct. Then show the correct nearby. Yeah, you can judge it. It's correct or not correct. Let me say problem for part B. Cosine is same as this. This is, yeah, okay, it's correct. Do you mean this is wrong?
Hmm?
Do you mean
Yeah,
negative 2 is wrong? You think
see.
answer is -1, right?
Yeah.
So show me where is this angle. Show in the unit circle.
Okay.
Where is its terminal place?
Oh, I see.
Could you show it?
Yeah. It's like wait. It's like here.
Okay, yeah. This is right place. Then suppose it's positive, right?
Mm-hmm.
Yeah, so this also not good. Now, what's the value?
This should be let me see.
It's
Is it
the
is it
reciprocal of sine, right?
yeah, is it wait a second. Is it is it 2 times square root of 3 over 3?
Yeah, could you write it?
Oh
You
yeah.
mean 2 times? Yeah, I think so. So this is pi over 3. So its sine is this, right? then take reciprocal. Yeah, this. Okay. Now let's go to part B. Uh, 61. There is A, B, C, D, E. Okay, let's try 61. Let's try it together. We are going to find the minimum value of the function. Set your calculator in the reading mode and complete the table. Round the value you obtain to 2 decimal places. Yeah, we'll pass this. Yeah, or maybe later we can use decimals to draw the graph of this, right?
Mhm.
So let's go to part B. Of the same output you calculate, which is the smallest, what is the corresponding input? Prove. Yeah, now go to C. Prove this equal to this. Think about how to prove this. You want to start from left side, let it go to right side, or start from right side to go to left side. Yeah, for me, I would like start from right side. Equal to, so tangent t square minus 6 tangent t cotangent t, right? Then plus 9 cotangent t square. Yeah, here too many t's. Then plus 6, right? Yeah, we know tangent t and cotangent t, they are reciprocal. So this just equal to 1. Then we have tangent t square plus 9 cotangent t square, which is the left side, right? Use the identity in part C to explain why this greater than or equal to 6. Yeah, because this is a complete square. We know only when this here equal to 0, you get its minimum value 0, right? Otherwise, it's always greater than the after square is always greater than 0. So part D is easy to explain. Now let's go to part E. The inequality part D tells us that f of t is never less than 6. When t minus 3, when this equal to 0, it get a minimum value 6, right? Minimum value. Yeah, so anyway, we go to, this is E. to find the minimum value, we should have tangent t minus 3 cotangent t equal to 0. Then, anyway, we have tangent t squared equal to 3. And don't forget t is within this. So we take tangent t equal to 3 square root, which means t actually is pi over 3. All right. Yeah, now let's use decimals to draw its graph. Then we observe the range, the interval from 0 to 2 pi, to find its minimum value. Yeah, before we go to decimals, you can take a screenshot for this. Okay. Now let me see. Yeah, I have decimals here. Yeah, we call y equal to tangent x. Oh, x squared plus 9 cotangent x, then x squared. All right. Yeah, from 0 to half pi. Now let's draw x equal to pi over 2. Yeah, so we just watching this. Well, let me write x greater equal to here don't have equal to, just less than, right? But x greater than 0. Yeah, so say just this, the minimum is here. Right? Now, do you guys want to try one? How about the 63? Good. Yeah, think about 63. New rate 63. Evaluate each side of the equation when t equal to this. Yeah, how about A for Neil, B for Ray?
Hello, hello. C'est nice, mais
Ooh.
you could find me when they're on the fun, you could have. The both here.
Yeah, Ray, suppose you just need to do part B.
Oh, that's.
But you already mentioned part A is correct. Means it's left side equal to right side.
Yeah.
Okay, fine. Keep go to finish part B. Neil, then you go to part C, think about if this is an identity.
Okay.
Ray, why you think it's identity?
Because they're equal.
Yeah, what means identity? Means t take any value, the equation always true, right?
Yeah.
Then we call it identity.
Mm-hmm.
Are you sure they are equal always? Or just sometimes?
Okay. Speak nicely.
Oh, they're not always. Yeah.
Yeah, not always.
Yeah, because there's a square.
How you know?
Because there's a square. So
Oh.
if a sign is negative, it would be different.
Okay, let me tell you. I already did it. Put all the terms in one side, then do factorize. You get 2 sine multiply sine t minus cosine t equal to 0, right? Oh
Mm-hmm.
no, hold, not equal to 0. Hold, let me see. When was this? Oh, okay, I make a mistake. Here is 2 sine t minus 1 multiply. Yeah, that means that we either let sine t equal to half, then it's true. Or sine t equal to cosine t, right?
Mm-hmm.
Only t take these two special value. This equation is true. For other values, for example, let's go to check another one. If t equal to, let me say, t equal to, for example, if t is pi over 2, then we know sine t is 1. So 2 times 1 minus 1, this is just 1. Sine t is 1, cosine t is 0. Then it's 1. 1 times 1 still 1. 1 not equal to 0, right?
Yes.
So anyway, it's not identity. No. Okay, now let's go to next section. graph of the sine and the cosine function. Yeah, then we need to mention about it's periodical. Yeah, this is complicated. So anyway, I will see how they call the function. They still use theta as input, represent angle, right? Yeah, but I suppose finally we'll just call it y equal to sine x, like all the regular function. This is input, this is output. Yeah, but they still use theta, which looks like angle. It's not bad. Mm. Yeah. Okay, let me quickly go through, then we'll go back. Cosine, here is definition, inverse, inverse of cosine. Okay, so for this section, excuse. Yeah, I'll just ask you guys, have you did this before? For example, y equal to sine. Yeah, let's just call it x. Or y equal to cosine x. Have you guys drawn this graph before?
Yeah.
Yeah, Ray did. How about Neil?
Yeah, I have to.
You have. Then
Yep.
can I let you guys each draw just one circle?
Like the
Yeah, from 0 to pi. Yeah, I'll calculate this for you. Yeah, hold. Yeah, give me one moment. Hold. Yeah, okay, I think this is good now. Yeah, you say pi is 2.28. It's just about here. No, here is 2 pi. Right. Then pi is about here. So
oh wait,
this by who? By Neil?
oh, I messed
Who?
up. Yeah, that was me, but I messed up, so I'm redoing it.
Okay, yeah. Found this. And don't forget here is 1. Here is -1. Ray, how about you do Ray do this? Neil do this.
Okay.
So half pi. Half pi is about here. Okay, Neil already finished. Ray, how about you? Cosine. Do you need help?
No, I'm just trying very slow.
Oh, okay.
Okay, yeah. Yep. Yeah, I think this is it.
Yeah, let me say. Yeah, basically speaking, it's correct. But it's more like this, right? This,
Yeah.
this. Then find, yeah, you just stop here. You don't need to keep going. Yeah, then it's a full circle.
Mhm.
Yeah, if you guys know this, we'll quickly pass this section, but let's review it again quickly.
Mhm.
Yeah, to save time. Periodical. The periodical is 2 pi. Amplitude. Maximum minus minimum divided by 2. Yeah. Then more points, then more accurate for the graph, right?
Mhm.
Property. Then this called use transform, right? If this is sine x, then for x plus 2 pi, x replaced by x plus 2 pi, it's move left pi over 2 unit. Oh, which is cosine, right? Okay. Yeah, then use the graph to find when cosine 1 is 0.8, what is x? It means this. Yeah, x1 equal to about yeah, here, right here. Yeah, let me draw it. When cosine equal to this, it's function 1. X is about 0.65. Then here talk about, let me see, inverse of cosine. Yeah, anyway, it means in your calculator, you should push the button this. Second, when when put second, it means go to cosine's inverse function, right? So they talk about the inverse function. Yeah, then here shows this denote the unique number in the interval 0 to pi, whose cosine is x. Then is this talk about the inverse of sine? By the way, it's also called arc cosine, right? See here. For inverse of cosine, we either denote as this or denote as this, arc cosine. Then I suppose it also talk about the arc sine. Let me say, let me quickly go to say sine. Why there is no arc sine? I suppose they should both mention. So anyway, I may have a question for you here. Inverse cosine function and inverse sine. Abbreviation is this. Okay, before we go to exercise, let me ask you. Y equal to sine x. Take this. Or just call arc. What is its domain? As a function, what is its domain? What is its range?
Negative infinity to infinity.
Yeah, how
And
about this for Neo? Then for Ray, y equal to cosine x -1. Or just call arc cosine x. Then domain and range. Domain. No, I don't think it's negative infinity to infinity. Don't forget here not sine. It's arc sine or inverse of sine. For
Wait, that didn't
arc
make
sine, the input is angle or it's a value. Suppose output is value, right? Oh no, sorry. Output is angle. Output is angle. Input is just a value. Yeah, for example, when x equal to this, suppose either arc sine or arc cosine equal to pi over pi over 4. That means that in degree 45 degree, right? Anyway, think it carefully. Now let me say, yeah, -1 to 1. Then here is negative. Okay, for 3. Now this is correct, but this is not. Yeah, this is wrong. This is wrong. Yeah, so how about let me quickly mention this. Yeah. You see here is a drawing for hold. I wanna drawing for sine, but this is not sine. This looks like sine, right? Correct? Hold. Let me just go back to sine. Where we have this is no. Hold. Sine. Yeah, suppose this is hold. Yeah, I'd better use this. So first we know only one-to-one function has inverse function, right? Am I right?
Mm-hmm.
Yeah. So for the whole sine, they don't have inverse function because it's not one-to-one. But as this is so important and not for application, we would like it has inverse function. Then we just pick one period, which is 1 to 1. Now this is a question for Neil. So which piece you wanna take? Yeah, for
Oh,
example, you can take this. You can also take this. You can also take this, right?
yeah.
Anyway,
I'll
for
go with the
you,
one in the middle.
could you like what I did just now,
I
mark
think maybe the one that, yeah, sure, the one that you just did, the one in the middle.
one in the middle, one in the middle. Hold on, let me undo. No. So could you draw it? Which one? Okay. Actually, no. The most popular one we want to use is from 0 to 2 pi. That means 0 to 90 degree, right?
Yeah.
We don't want to miss this. So if it's this, we miss the most basic one, right? So let me tell you, it's this one. That being said, from negative half pi to half pi. Yeah, it's this, to half pi. So that means that for, if I call g of x, which is arc sin x, then its input is value instead of angle. So of course it's from negative one to one, right? So its domain, its domain is negative 1 to 1. So its range is from negative 2 pi to, oh, sorry, negative half pi to half pi. It's this. This is for arc sine. Yeah, you can have a screenshot. Then I'll ask Ray. Are you done?
Okay.
Okay, you're done. Now let me go to cosine, then ask Ray. Cosine. Yeah.
Wait, isn't that cosine?
Yeah, this is cosine, right?
Uh-huh.
Again, for the whole cosine function, it's not one-to-one function. So suppose there is no inverse function. But again, we wanna take one interval, one piece, which is one-to-one. Then it can has inverse function, right? So
Maybe
now, which piece you wanna take? Show me.
let me see.
Y equal to arc
This part,
cosine x.
maybe
This part. Yeah, kind of good. This is one-to-one, I agree. But don't forget, we always want this most popular one, right?
Oh,
Don't miss this most popular one. Then, do you want to pick again? That means we always want to include from 0 degree to 90 degree. This is what happens in triangle, or right triangle. Yeah, now it's correct, but you can keep going to
在
here.
讲题。
Yeah, so it's from here to here, okay? Then again, so its domain is arc cosine. Yeah, it's from negative 1 to 1. Its range is from 0 to pi, right? Yeah. For example, when we need to find arc cosine equal to half, this equal to what? Then another question, arc cosine negative is equal to what? Yeah, it's just like in this period, there is a place this equal to half, then its corresponding angle is what, right?
Mm-hmm.
Then can you guys answer? For example, Neil answer this. Neil answer this. Ray answer this. Then for this, it's like in this period, you just go to find the negative 3 radical over 2 is about here. Then this angle is what, right? No, this is negative 60 degree is wrong. Why? It's in this interval, 0 to pi. Not go this way, not here. It's not in the range. Understand?
Mm-hmm.
Yeah, you can either write the angle in degree or in radians. Both good. So Neil, your question is like among 0 to pi, which angle has cosine equal to half? Then it's the answer here. Right?
Oh, so 60 degrees.
Yeah, 60 degree. That being said, pi over 3, right? Right?
Yeah.
Ray, how about you? Also, your question like among 0 to pi, which angle has cosine equal to negative 3 radical over 2?
Oh, I see. Wait. Is it negative 5 pi over 3?
Negative. No, this is not within 0 to pi.
Oh, yeah.
Yeah,
So
it
it's
must in this range.
so it's 5 pi over 3.
5 pi. What's the difference? What's the difference? No difference. Yes, so actually it's right. 5 pi over 6. That means that it's 150 degree, right? The reason is cosine 30 degree equal to this. Then cosine of this equal to negative of this. Yeah, anyway, it's this. The answer is this.
Mm-hmm.
Okay, let's take a break.
Okay.
Yeah. Yeah, now you can see the interval for cosine. No, inverse of cosine and the inverse of sine, right? They are different. Inverse cosine, the interval is 0 to pi, inclusive. This is negative half pi to pi, to half pi, inclusive. Now let's go to do some exercise. Part B. And let's do one. Specify period and amplitude. How about Leo do this, Ray do this? Period just call P. Amplitude just call A.
Well, what are we supposed to find?
Find
Period
the
and amplitude.
period and amplitude.
Oh, okay. Wait, what's this one?
That's the period.
Oh,
Okay, 4, 6. Yeah, so for
Probably the
here,
amplitude is the distance from the middle and the top or bottom.
Here, period is okay. From here to here is a accompanied period, right? So the period is 20.
okay.
Then amplitude from here -5. Here is -15. So the difference is 10. But we need to divide by 2. So amplitude is 5. Yeah, then we'll find a problem about the inverse of sine or cosine. Maybe we'll go to part B. Let's see if we can find the It doesn't mention where has this kind of they don't for this textbook they don't mention. Yeah, how about let's go here. Let's just do this. Refer to the following figure which shows the graph. When the value of sine x is a maximum, what is the corresponding value of cosine x? Okay, so blue is for sine, right? Max value happen here. When x is equal to half pi, at here the cosine just 0, right? Then B, when the value of cosine x is a maximum, here, means when the angle is 0, right? Then sine is also 0. Now let me ask a question. When sine x equal to cosine x, can you guess answer?
It's when a equals to pi over 4.
pi over 4, right?
Yeah.
But this is just one of the place.
Yep.
During this period, we have another place. What's this angle?
That is I think it's 3 pi over 4.
3 pi over 4. No, suppose it's greater than pi, right?
Oh yeah.
So suppose it's 5 pi over 4, right?
Yeah.
Hmm. Okay, let's pass through this section. Graph of yeah. If you know, if you are good in the knowledge of function transformation, then suppose this is not hard for you, right?
Mm-hmm.
Anyway, yeah, let's just identify. Yeah, for example, let me have one. Let me have one. Let me. This is for Neo. Let's start from parent function is y equal to sine x. Then here, let me show you one y equal to -5 sine 2x minus 6. Right? Yeah, how
Would you
you
graph that?
no, you just show how you transform it from parent function to get this. Then for ray, of course, the parent function is this, right? Cosine.
Honestly, I think graphing it is easier, but
Uh,
first you multiply it by -5,
uh,
and then you
yeah,
I don't
that's
know how.
okay. So Neil, starting from here, I suppose you mean first that you go to get -5. Okay,
Okay,
you write it. You write it. Yeah, I would like you write it. Ray, you go to get y final equal to, how about -3 cosine 5x plus 10. Yeah. Okay, Neil, looks like you already done. Then please tell from here to here, this is what kind of a transform?
uh stretches vertically by 5, I think, and reflects across y-axis.
Actually, so that means that it's two kind of transform, right?
Yeah,
Yeah, and it's not reflected by y-axis,
I
it by
mean
x-axis.
x-axis. Yeah, I'm in x-axis.
Yeah, x-axis. Yeah. Anyway, so actually, this means two steps. Then keep
Okay,
going from
and then
here
the next
to here. What's this?
stretch horizontally by 1/2.
Yeah, so horizontal shrink, right?
Yeah,
Then finally, what's this?
shift translate right by 6.
Wrong. It's wrong.
It's not.
Not 6
Oh
units.
wait. Translate right by 3.
Yeah, because here you show like x replaced by x minus 3, right? So it's not 6 unit. Let me write go right, but 3 unit. All right. Okay, then we're done. Now let's say how we make this from here to here.
So first it stretches vertically by 3. I mean by 3 actually.
Yeah.
And then it like stretches vertically. I mean, wait, is it no, it's not vertically. It's horizontally.
Okay,
by
here
1.
you have one more step. Means reflect by x-axis.
Oh,
Right.
okay.
It means when the function value take operate, then it means reflect about the x-axis. If it's f of x, go to f of negative x. That means x replaced by negative. Then it means reflect by y-axis. Right? Yeah. Anyway, then keep going. Let me use different color from here to here. That means that x replaced by 5x. Right? Then this is what kind of transform?
This is also stretching.
Vertical or horizontal?
It's horizontal.
Yeah, but it's not straight. This time it's 5 greater than 1. Then it's actually shrink.
Okay.
Yeah, like what I mentioned here, it's shrink. Then finally, from here to here, what will happen?
It transforms to the left for 10 units.
No, here is left.
Yeah, left.
But just 2 unit.
Oh.
Because it just means 5x replaced by 5 of x plus 2, right?
Oh, okay.
You say x replaced by x plus 2 instead of replaced by x plus 10. Okay, yeah, please take a screenshot. You done?
Yeah.
Now let's quickly go through this section. Yeah, for trigonometric function, of course, there is something like a period, right? When here x replaced by b of x, then the period also change. The reason is, for sine and cosine, if the input add 2 pi or multiple of 2 pi, then it has the same function value. That means that it's repeat, right? Repeat. So you say if it's just x, then we need x plus 2 pi. But if it's bx, then we just need to add x b of 2 pi, because this will multiply b, right? So here show the new period, correct?
Yeah.
Yeah, if x go to x, replaced by x plus 2 pi, they have same function value. But if it's bx, we just need to add 2 pi over b to x. Then when time b, actually we add 2 pi. Now let's see. When we multiply -2 to the function, negative means reflect about the x-axis. 2 means stretch, right? Now this will show the period change. So here show the new period. Yeah, anyway. So when here go to b of cosine bx, then the new period go to 2 pi divided by b, right? So when b is 3, so we get this, 2 pi over 3. Yeah, it's better the textbook show a general formula. Okay, here shows the core concept, right? Property. Yeah, anyway, just think about the transform. Here is a important concept of phase shift. Yeah, please read through this highlight one. Equal to x equal to c over b. So they mention c over b cause a phase shift, right? So if so, do you think phase shift is always positive or it can be negative?
I think it could be negative, I guess.
Yeah, because if C and B has different sign, right,
Mm.
then it's negative. Okay. Yeah, so just use the formula, right? Graph. Oh, excuse me. So when you graph this, actually you have two methods. Let me mention this. One is use function transform, right? Correct?
Mm-hmm.
Yeah. Another is you say this is cosine. We know for cosine from 0 to 2 pi is a one coperiod, right?
Mm.
Then you can just take when this equal to 0, it's the starting of a period. When this equal to 2 pi, is the end of the period. Then of course during this, normally we found 5 point, right? 5 point. That means 0, half pi, pi. Oh, hold on, pi is not here. Pi. Okay, this should go this way. Here is pi, then 3 pi over 2, then finally 2 pi, right? So find the 5 key point. Then you can do a whole period. Yeah, we can try this. Yeah, how about we just let this to try? Yeah, we'll not see what it did. Now let's do, yeah, think about this. Let me call is just input, so I just call it I, okay? So go to calculator when I equal to 0, then x equal to what? Then g equal to what? All right, yeah, let's make kind of make table. We need 5 place, so 1, 2, this is 3, 4, 5. Yeah, let me do the last one. When this equal to 2 pi, I equal to, oh, hold, that's, sorry, need a bit of, this call I equal to what? I equal to 0, half pi, pi, 3 pi over 2, then finally 2 pi, right? So let me calculate one, then each of you calculate another one. How about I take the middle, pi? If this equal to pi x plus equal to pi, then pi x equal to negative, oh, hold, not negative, just pi over 3, right? Then x equal to 1 over 3. So that means that when I equal to pi, then x should be 1 over 3. And the function value is, as this is pi, we know cosine pi just equal to -1. So -1 times -2, I get this, right? So I finish 1 point. We just need this 5 key point. Now let me sign job for you. Purple color. Purple color for Neo. Then the left for Ray. Okay. Sorry, let me say if
So I
can.
do X.
No. Neo do when I equal to 0 and when I equal to 3 pi over 2. Ray do what left? Ray do this. Oh, come on.
So confused.
Ray do this. Oh, come on. Ray. And, oh, no. I already did this. Sorry. Ray do this. Half pi. And 2 pi.
So I do 2 pi and pi over 2, right? Okay.
Yeah, let me see if I can let this go small. Oh, no. Sorry, guys. Yeah, I move them. Yeah, that's the most big thing I can do. Yeah, I call all this as I, means input. This equal to 0. Yeah, purple for Neo. This is by James. Right. Ooh.
Kind of confused, honestly, on what to do.
Oh, okay. For Neil, you see here when I equal to 0, means this pi x plus 2 pi over 3 equal to 0. Then you can solve x equal to what, right?
Oh, okay. So for this, x would
Yeah.
Equal to -2/3.
Yeah. Yeah. So write it. Yeah, maybe you don't need to write x because in the top we no you don't need it. We mention this column means x equal to what, right?
Okay.
Okay, then g equal to what? As this is 0, we know cosine is 0, just 1. 1 times -2. So it's -2, right?
For g,
Yeah, g equal to -2.
times wait, can you repeat that again? Sorry.
Yeah, you say this input equal to 0, right?
Yeah.
Then cosine of 0 equal to 1, correct?
Yeah.
Then keep multiplying -2. See here. So you get -2. It's correct.
Okay.
Yeah, then now you do this. When input equal to, you say this means input equal to 3 pi over 2, then x equal to what? X equal to what? Yeah, right here. Then function value is what? In this way, we'll find this 5 key point to draw one period of this function.
And then this would be
Yeah.
wait, 2 pi over 2. I got this.
Yeah, I think this is correct.
Okay.
Then how about here? Then I suppose here maybe not correct, right? Because we're -2, then go to 0, then go to 2, then go back to 0, go back to -2. So I suppose here is 0. Yeah, you say when here is 2 pi over 3, 2 pi over 3, yeah, suppose this is 0, then multiply -2 is also 0, right? So do you guys get this point?
Yeah, I
To
think
draw this, we just need a 5 key point. This 5 key point just means when cosine, input for cosine is 0, half pi, pi, uh, 3 pi over 2, then finally 2 pi. It's the 5 key point we want. And which definitely show the maximum value, minimum value. Okay, you can take a screenshot for this. You done? Yeah, even we
yes.
can go to find what kind of point this make. Yeah, here is the final one. in what kind of corner? Okay, we'll forget this. Yeah, anyway, this is a way not by transform, because sometimes for transformation you need several steps. It's also very complicated, right? Yeah, then we will not do this anymore. We'll just go to next section. This simple harmony motion. Yeah, this related to physics. You just go to get its function, which is a trigonometric. Either use cosine or sine. So now you can cosine actually you can transform to in sine form, right? And sine form can transform to cosine, right?
Yep.
Okay, so 8.4 will just jump. Find graph of the tangent and the reciprocal function. Now let's talk about the tangent. Y equal to tangent x. Yeah, even we'll talk about its reverse function. Y equal to arc tangent x. Now first ask this, what is its domain? What is its range? Yeah, if we divide into Neil, you can write left side. Ray, if you want, you can write right side. Okay.
Okay.
Yeah, just for tangent. So let me even cancel this first. Cancel the. Oh. Mm. Okay. So Neil is correct. So this, we know for tangent, it's if we call this terminal point x, y, so tangent is y over x, right? Then the x coordinate cannot be 0. That being said, at this place and this place, tangent is undefined, right? So now the period go to, let me see. Now for tangent x, its period is not 2 pi, it's just pi. Yeah, this is because another thing you say, if this is xy, so here is negative x, negative y, right? So they have same tangent, correct?
Mm-hmm.
Yeah, that being said, tangent x plus pi equal to tangent x. Anyway, the period is pi. Then if you go to draw tangent, let me clear all this. Yeah, how about let's go to a decimals. Yeah, if you want to draw tangent, y equal to, come on, tangent x. Come on. You just need to find the period. Then we know it cannot be negative half pi to half pi. So this is not like its isent, right? Then you can draw it, find some point. For example, when angle is 0, tangent also 0. When x is half pi, it's so anyway, let me use decimals quickly draw it. Y, yeah, here I show this is not correct. It's not on the 1. Instead, it should be half pi, which is 1.57 about, right? So it's about here, which is the asymptote. So it's about here. Now let me use excuse me. Yeah, as you guys mentioned, the range is negative infinity to infinity, right? Now again, for the whole tangent, there is no inverse function, right? But if we want to let it have inverse function, we'll just pick one interval. So tell me which interval you want to take. Interval. This time, let me do it. We'll always include from 0 to half pi. That means this will always include, right? Then, of course, we take this, right? Instead of go to take like this, right? We will not do this way. If we use this, it's a continuous interval. So anyway, that means that we choose from negative half pi to half pi. So the arc tangent x is within, let me say, arc cosine, x is within, the domain is, this is domain. Range is negative infinity to infinity. Now let me change the color for this. Domain for arc tangent. It's the range of the tangent x, so it's negative infinity to infinity. All right. Then for range, it's negative half pi to half pi. By the way, this is wrong. Not include, right? Yeah, okay, that's for tangent. Yeah, again, if you want, you can take a screenshot.
Mm-hmm.
Yeah. Yeah, anyway, show period is pi. That's for tangent. Make sure with the domain and run. That's for tangent. Then transform. Tangent b of x. So the new period will go to pi over b, right? Now talk about the cotangent. Again, make sure with its domain for the cotangent. We know cotangent is the coordinate x over y. Then y cannot be 0, right? Yeah, that means that the angle cannot be 0 or pi, or the just call is k pi. Anyway, it's similar to tangent. Then we go to secant and cosecant. First, show what? Cosecant. We know cosecant is reciprocal of sine x. Then sine x cannot be 0, right? That means that the domain cannot be all real number. You must accept some place. Okay, so let's quickly finish this. Then for secant, similar thing is 1 over cosine. So cosine cannot be 0. Okay, I suppose that's all for this chapter. Again, you go to do chapter test. Here. Yeah, if you meet something, you cannot go through, just mark as you need help. Okay, I will see you guys next week.
Okay, thank
Okay,
you.
bye-bye.
Thank
See
you.
you.
Bye.
Bye.